from Idaho. I strive to provide interesting videos about motorcycles, fabrication, welding, electronics, machining, and general creativity. I hope you enjoy.
Hello from Idaho. Well, it's November. Time to make a few Christmas gifts on the milling machine. And typically I make fairly small things with engraving or pictures or whatever. And that leads me to my next project. You can see that that operation finished and I'm ready for a tool change. Well, the last thing I cut for a gift ran 7 hours. And I would come out and check on it occasionally and make sure I hadn't broken a tool or it wasn't cutting the table or whatever. But then I forgot about it and it finished, and it was an hour or two before I came out and changed tools, and so I lost all that productivity time. So what I want is a tool change alarm, something that will notify me personally if I'm not in the shop. I might be doing yard work, I might be in on the computer. You never know where I am when a long program is running. And so, as usual, I started searching the internet for CNC mill tool change alarms. And surprisingly, there is almost none. I found exactly one, produced 7 years ago or so. Not that that matters, it's still relevant, by NYC CNC. And if you follow any sort of hobby or even commercial machining, you know about John in NYC CNC. He has put together enough videos that you can learn to be a machinist from your computer chair if you just pay attention a little bit. At any rate, he and I had about the same requirements. I don't want to modify the mill very much, if any. I certainly don't want to connect up to its electronics. I don't want PassPilot to talk to the internet. It needs to be something simple. And he came up with a good idea. Inside the electronics cabinet, there's an LED that comes on every time the spindle runs. And then when the spindle stops, the LED goes off. The other method I found is that the VFD puts out a 24-volt signal to let you know that the spindle is running. And I have used that signal before on my electronic cooling of my drive motor. And so I started doing research and looking at electronics that sense light, and I ordered up the widest range of resistance. So this is a cadmium sulfide cell, and it senses light, and it changes resistance as the light changes. When it's dark, it's 5 mega ohms or more, and when it's light, it can get down to 40 kilo ohms. That's a wide range, and I chose it specifically for that. One concern is that these things are very narrow band, so it's centered on 550 nanometers wavelength of light, and LEDs are very narrow band. They put out a very narrow band of light, and the one that's in the mill today is yellow, and so that's not 550 nanometers. It's a little bit higher than that. It's like 590 or 600 or something like that. And so I don't know how much sensitivity I'm going to lose by driving something that's centered on green with a yellow light. So I got that experiment to do. And then the NYC CNC solution was to buy a box called twine, and I'll put a link here to John's video. It's still pertinent today. Basically a piece of electronics called twine that does internet things and whatnot, and a little Arduino which would listen to the sensor and drive the twine, and that's how he got on the air. Well, 7 years has passed, and I thought there must be a better way, so I started looking for devices that I could modify that in their normal operation would send a text. And so after a week or so of poking around the internet on my free time, I found this little gizmo. It's called SimpleSense, and it is ostensibly designed to detect flooding. So let's say you put it in your laundry room next to your water heater. It has two continuous strips that are held off the floor a millimeter or so. And so when the water rises up a millimeter, why, it makes contact between those two sensors, and the device sends out a text message that says it's detected a leak. And then when the water subsides, it sends out another text message that says the problem has been resolved. Well, this conduction path right here is fairly high impedance. You can trigger it with a wetted finger. And I don't know if you can hear those beeps over the fan running on my mill, but it basically just sent a text, and the text will come out on my phone, which I'm using to record this. And so I believe the simplest possible solution is to put this CDS cell across those two pads, and if it's sensitive enough to yellow light, when the light comes on, it will look like flooding, and this thing will send out a message. And then when the light goes off, it will look like the flooding has been fixed, and this device will send out another text message. So this is like 40 bucks. I bought it off of Amazon. I don't do unboxings, they're stupid, but you do get this great manual. It tells you how to set the device up on your wireless system. So I don't connect to the electronics here at all, except for mount this little CDS cell to where it can see the LED in the electronics cabinet. And then this the instructions are very well written, and it makes it really easy for you to connect this up to your wireless. You need to know your wireless password, and you have to have an email account and a phone number that it can text, and that's as complicated as it gets. So I'm going to open the cabinet, start the spindle, and take some measurements on that LED. Measure the voltage drop across it while it's on. And then, because if this thing doesn't sense yellow well enough, I'll just solder in a green LED in place of the yellow one. But I need to know a little bit about what parameters the LED is operating on now, so that I can pick out a correct LED that will fit in there, be electrically the same, but put out green light. Now, I'm not going to want this thing on all the time, and I don't believe this thing could transmit outside of the electronics cabinet, since it's all metal. It's essentially a Faraday cage. And so I will the plan, if this CDS system works, is to hook this, make a little bracket that holds this in front of the LED, put some wires on it, run it out, and then put this thing and a switch that will break this circuit on the outside of the mill where I can reach it. Because when I'm doing setup or short runs or whatever, I don't want text messages. And so I'll just break the continuity between the cell and the sender for the times when I want it off. Excuse me. One of the good things about this thing is it's alleged to have a 2-year battery life. One of the other good things is that there's a little application that you put on your phone, and if you open the application, it shows you what the battery life is and what sort of wireless signal this thing and the router has, how good the connection is between this thing and your wireless modem. See if we can tin the little sensor bars. I know they can be soldered to because I saw the soldering joints inside. Yeah, they're taking solder just fine. So we'll put a piece of black tape across the sensor. Maybe that'll be better than my thumb. And solder it on. Take the tape off. See if we get a text message that says leaking. All right, I heard a beep. And there's my text that says, leak detected. Okay, so far we've shown that the CDS cell will work. So the next step is to figure out how to attach the CDS cell to the LED. And I think the easiest way to do that is with a little sleeve. It's only 3/8 of an inch long and 3/8 of an inch tall in diameter. And this little recess here is for the CDS cell. This little recess here is for the LED, so they're going to be really, really close to each other within about 15 thousandths of an inch. And I've got some 1/2 inch Delrin here that I think we'll make it out of. It's a little bit hard to glue to, but it is non-conductive and it's black, and so we'll try that at first. It certainly will work for a test. Okay, I got my little part made, and we're about ready to test it on the mill. I'm going to test it with the door open. So the milling machine is running. I'm going to use manual start and stop. Here's my telephone, which we should be able to hear the alarm. Okay, I got the CDS sensor in the little part, and I put it over the LED and hold it there. Okay, now we're going to start the mill. Okay, it's detected the mill on. Now I'm going to turn it off. Okay, that's my phone getting the first test message that says we were on. And that's my phone getting the second text message saying that we're off. So the damn thing works. Yay! Okay, I couldn't convince myself to use this CDS cell holder. I would have had to glue it on or try to wrap some tape around the LED, and then I would have had to tape or glue in the CDS cell. That just didn't sit right with me, so I've changed the plan a little bit. This was great for the test and led us to this next part. So I've made a positive clamp for the CDS cell. This screw goes through the top and screws into the bottom foot, and so you tighten this screw here and it clamps it to the PC board. Pretend like this piece of PVC is a PC board. This screw right here positively holds in the CDS cell, and the LED is sticking up out of the PC board, and this goes over the top of it. So with it located by the LED and this foot, I should never have any trouble with it vibrating off or coming loose or having the glue get old and break or whatever. And this will withstand vibration and whatnot for a long time, so I'm happier with this. Okay, here is the sensor mounted to a piece of 1/8 inch PVC. It's going to mount to the top of the electronics cabinet with these two screws, and I'll put nut certs into the top of the electronics cabinet. The little cutout here is for the wires to come through, and I've also applied a layer of epoxy to this connection, so there's no wire that you can get to that could be accidentally touched and send a false signal. So that's going to go on top of the electronics cabinet, and it'll be up high enough and away from enough stuff. I think it'll provide a good connection to the wireless. Okay, the installation is complete. There's the leak detector on top. I've marked which end I need to put a screwdriver in order to replace the battery. That's what that writing is. The wire comes down along, gets bundled in here, goes into that channel, and then goes into the back of the switch. The CDS cell is in its little bracket, clamped to the side of the PC board, and the wiring goes up into the wiring trough, over and up, and then gets bundled in here and goes over to the back of the switch. And that's all the milling machine modifications there are. Here's the switch. Up is text, down is no text. Okay, project done. Got all the wiring done, the switch in, got the switch labeled. Sensor box mounted on top of the milling machine. Okay, we'll turn the switch to text on and run it again. Okay, I just got a text that says a leak is detected. And I got another text that says the leak is resolved. And so that's one of the downsides to this solution that I can't really do anything about, since that sensor is ostensibly to report on leaks and the content of the text message is controlled by that company, Simple Sense. Then I'm just going to need to remember that leaking means that I've started the spindle, and resolved means that it's time for a tool change, or maybe possibly even we run out of a limit, we hit in the limit switch, or a crash or whatever. But generally it's going to be a tool change. And so I'm very happy with this solution. It's about 50 bucks. I looked up the Simple Sense thing on Amazon last night. It's $50. CDS sells about $3, so I got $55 in it. Dug a switch out of the junk pile. If I had to buy a switch, it'd be another $5. But basically, it's pretty cheap for what it does. So the NYC&C solution that I got my inspiration from was about $150. Now, clearly, it was a lot more flexible. The text messages could say exactly what John wanted, and with a twine box, you can do a whole lot more than this little leak detector. But for my little simple application, where I don't have a tool changer and I don't want one, sure, I'm not a production shop, I do hobbyist stuff, and so running one tool at a time is fine for me. And now with the tool change alarm, I think I have almost the ideal situation. So thanks for watching, and goodbye from Idaho. As usual, if you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments, and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.